Zeal Education Society, redefining excellence.
Good morning to everyone, and myself, Dr. Mahadev Unde, Professor in Electrical Engineering, Zeal College of Engineering and Research, Pune. In this video lecture, we are going to learn the synchronous motor, that is the principle of operation of the synchronous motor and its construction. Pay attention, the construction of three-phase synchronous motor is same as that of the synchronous generator. It consists of the stator and rotor. Stator is a stationary part on which armature winding is placed, and the armature winding is generally distributed short pitched winding. And the winding may be either star connected or delta connected, and it is supplied by three-phase AC supply. Now the rotor consists of the feed winding. The rotor consists of field winding, and this is the feed winding which is generally excited by the DC source. And to the motor, the coupling is provided to which mechanical load is connected. So the rotor on which field winding is placed is excited by the DC source, and thus the motor, stator and rotor. Stator is excited by the three-phase AC supply, whereas the rotor is excited by the DC source, and that's why synchronous motor is known as doubly fed motor. Okay, so it is a doubly fed motor. And what are the peculiar characteristics of the synchronous motor? Synchronous motor runs either at a synchronous speed or not at all. The synchronous speed is given by Ns equal to 120 F upon P. Only way to change its speed is by changing its frequency, F equal to Pn upon 120. Now, second point is it is inherently not self-starting. We have to make it self-starting by some means. So it is inherently not self-starting, and the most important and third point is it operates over a wide range of power factor, that is from lagging power factor, leading power factor, or a lagging unity to a leading power factor, simply by changing the feed excitation. So these are the features of the synchronous motor. Now let us see the principle of operation of the synchronous motor. Now see the stator, pay attention once again, this is the stator. The stator of synchronous motor, three-phase induction motor and synchronous generator is same, the construction is same. Okay. Now the three-phase supply is fed to the three-phase armature winding. The armature winding is placed on the stator. Okay, this is the armature winding. And this one is rotor at a particular instant. Here it is north pole and here it is south pole for the rotor. Okay. Now as soon as the three-phase supply is fed to the three-phase stator winding, that is armature winding, it produces the rotating magnetic field which rotates at a synchronous speed given by Ns equal to 120 F upon P, and that is of constant magnitude. That resultant magnitude is MF equal to 1.5 times phi max. Now at a particular instant, the stator poles lies along the line AB. Say NS is the north pole of the stator at the position of A, and SS, south pole of the stator, along the point B. So this NS and SS lies along the AB, that is at a particular instant. Now at the same instant, the rotor pole positions are as shown. Rotor pole positions are as shown. Now remember here, the rotating magnetic field produced by the stator is rotating in a clockwise direction. Okay, and it is expected that rotor also should rotate in the same direction. But see what is happening here, the similar poles, north pole of the stator and north pole of the rotor, repel each other. Similarly here the south pole of the stator and south pole of the rotor repel each other. But what happens after a half a cycle later? The stator changes their position instantaneously. See, AB position is same, but at position A, now there is a stator pole, stator south pole of the stator, and at B, north pole of the stator. Now see what is happening because of this. the rotor north pole and stator south poles are close to each other. Because of dissimilar pole attract each other, rotor tries to rotate in a clockwise direction. So we found that for a frequency of 50 Hertz, remember that the frequency 50 Hertz means in 1 second there are 50 cycles, and one cycle has a 1 positive half and 1 negative half, and therefore in a 1 second there are 50 positive half and 50 negative half. In other words, the rotor tries to rotate 50 times in forward direction and 50 times in backward direction in a 1 second. But owing to large moment of inertia of the rotor, it cannot move so fast and hence remain stationary. In other words, we can say the torque exerted on the rotor is not uniform or unidirectional. Not unidirectional, it is pulsating in nature. Pulsating in nature means like a sinusoidal, sometimes positive, sometimes negative. And therefore, in other words, the net torque exerted on the rotor is zero. And thus, the synchronous motor is not self-starting. However, if its rotor is rotated by some external means at a synchronous speed, and AC and DC supply is fed, there will be a magnetic locking between stator poles and stator say south pole and rotor north pole, means dissimilar poles. Magnetic locking between them takes place and rotor continues to rotate at a synchronous speed in the same direction as that of the stator field. So how to achieve this one? How to achieve this one? This can be obtained by means of first, the method of starting the synchronous motor by making the motor self-starting by means of using the damper winding, by using the wound rotor. These are the simplest method, and other methods are very conventional, old age methods, that is use of pony motor, small motor, and use of small DC shunt motor. Let us discuss this funda, the use of damper windings. Now, what is the damper winding and where it is placed? Generally, the damper winding is placed in the rotor pole shoots, and this damper winding is nothing but heavy aluminum or copper bars. See, these are the damper bars. Heavy aluminum or copper bars placed in the pole shoots. See, this is the pole shoots, and they are short circuited on both the sides by end ring. This is end ring. So, damper bars, and it is laminated, and pole shoes and pole cores are laminated. So this forms a closed circuit, and the rotor formed by the the damper winding is just like a squirrel cage rotor. So rotor behaves like a squirrel cage motor, and thus when the three-phase supply is fed to the stator winding, it produces the rotating magnetic field which rotates at a synchronous speed, and rotor starts rotating. This rotating magnetic flux passes through the air gap and cuts the stationary rotor conductors and produces according to Faraday's laws of electromagnetic induction, EMF get induced in the rotor conductors. As the rotor conductors are short-circuited permanently by themselves, the current starts flowing through the rotor conductors according to the Lenz's law. That is, it opposes the very cause producing it, and in this way, the rotor starts rotating in the same direction as that of the stator rotating field. In other words, the synchronous motor starts rotating like a squirrel cage induction motor near to synchronous speed. At this stage, excite the field winding by a DC source. So that will create the north pole and south pole of the rotor. And as it is running very close to synchronous speed, at a particular instant, the rotor pulls into synchronism by making peculiar noise. That means there is a magnetic locking between stator pole and a rotor pole of opposite polarity. And this magnetic locking continues the rotation of the rotor at a synchronous speed. So in this way, the synchronous motor can be made self-starting by using the damper winding and which rotates at a synchronous speed. So this is the schematic diagram for the damper winding and the feed winding. Okay, and this is the structural diagram. Now making the synchronous motor self-starting by using the wound rotor. Now already we have studied the squirrel cage induction motor and wound rotor. Wound rotor means its rotor is also wound with a three-phase distributed winding. So the stator, as usual, it is an armature winding. It may be either star connected or delta connected. But the rotor is always star connected. In order to add the external resistance in the rotor circuit, the slip ring and brush arrangement is also shown here. This slip rings lies on the shaft and insulated from themselves. And slip rings rest on the, brushes rest on the slip rings. Via the brushes, the three-phase star-connected rheostat can be used. Variable rheostat can be used in order to add the external resistance in the rotor circuit to improve the starting torque of the motor. See, here it is, the triple pole double throw switch is used. On the right hand side, the external star-connected external resistance is connected, and on the left hand side, DC source can be connected. So while starting, the switch is kept on the right hand side and gradually cut off the resistance, motor catches the speed, and when it runs near to synchronous speed, then excite the same winding by a DC source. Observe here the positive and negative. Positive goes to this R phase, it carries the current I, and remaining two winding carries the half current. Okay, so in this way we can make the synchronous motor self-starting. Okay, and such a kind of motor is also known as synchronous induction motor, which produces more starting torque as compared to the synchronous motor for the same armature current. It has many advantages as compared to the normal synchronous motor. Now the other two methods are, or in this method, pay attention. See here, the same thing is shown here, except that instead of using the separate DC source, here the exciter is kept. Exciter is the small DC shunt generator which is kept on the same shaft, and through the slip rings and brushes, the DC supply is fed to the field winding of the synchronous induction motor, that is known as wound rotor or synchronous induction motor, self-excited synchronous induction motor. This is the change only. Exciter is used, means instead of separate DC source, the self-excited means exciter is kept on the rotor and it is made self-exciter. Okay, rest of the things are same here. Okay, students. Now the next method is using the small DC shunt motor. Now here in this case, the three-phase armature winding is supplied by a three-phase AC supply. And the rotor is fed by the DC source, and it is coupled to the DC shunt motor. Now apply the three-phase AC supply to the armature winding of the synchronous motor. Run the synchronous motor near to synchronous speed by using the DC motor. Then feed the small DC excitation to the field winding, which creates north pole and south pole of the rotor. Rotor pulls into synchronism, that is magnetic locking between stator poles and rotor poles of opposite polarity takes place. Then decouple the DC shunt motor. This is very old and traditional method. Nowadays such methods are not used. And say the next one is by using the small pony induction motor. The method is same except the shunt motor, here the pony small AC induction motor is used. Rest of the things are same. Okay, so in this way we have learned the construction, principle of operation of the synchronous motor, how it is not self-starting, how to make it self-starting by using the damper winding, by using the wound rotor, by using the external DC shunt motor, and by using the external small pony motors. Okay, we will stop here. Thank you very much.